Hi, in this video, we are going to see the topic of left recursion and left factoring. So this topic comes in context-free with context-free grammar in formal languages and automata theory and in compiler design where we are dealing with context-free grammars. So we know that what a grammar is of. A grammar consists of four tuples, set of non-terminals, set of terminals, start symbol, and productions. So when coming with the productions, when a production is in the form A derives A alpha. So what is the meaning? Alpha represents the string that is followed after the first non-terminal. So when it is having A and A, calling a non-terminal by itself. So this kind of situation is called as left recursion, and it is of two types. One is direct left recursion, other one is indirect left recursion. So direct A derives A, whereas indirect is that yes derives A and that A derives yes. So it is indirectly specifying the left recursion. So when A is being substituted with yes, it is a left recursion here. So how to eliminate left recursion is that, so for elimination of the direct left recursion, we just follow the Morse method where when we have a format of the production, A derives A alpha or beta, then it can be directly substituted with A derives beta A dash derives alpha A dash or null. The same, this becomes, so the left hand side box consists of the left recursive grammar, whereas right hand side box consists of the non-left recursive grammar. Why it is important? Because parsers cannot be generated with the left recursive grammars. So we have to remove it. Now how it is been removed? So yes, the same example with an example, the same implementation. So when we are having the grammar, right? So what is being specified here? We are having yes derives yes, T derives T, F derives F. So all the three are direct left recursion. So what we are going to do is that we are going to take it in the format of A derives A alpha or beta. This is beta. So what happens? So we are just going to convert it to the formula that is being specified in the Morse method directly. So by introducing a new non-terminal S dash, we are making it as a removing of left recursion. That means S derives T now after left recursion removal, and S dash derives A, S dash derives null. So there is no left recursion in the converted grammar. So the same manner it is being specified here where here T is A, CD is alpha, and the red color represents the alpha, the remaining of the string after the not terminal, and then the F specifies the beta part. The green color specifies the beta part. So after elimination of the left recursion, the grammar becomes as so we cannot find a non-terminal calling its non-terminal in the right-hand side production. So it is S derives T, S dash derives A and null, and T derives F, T dash derives C and null, and F derives G, and F derives A and null. So a left recursion has been removed in this grammar. So when it is indirect left recursion, we have to follow the algorithm that by renaming the non-terminals, we are making it as A1, A2. So that what happens means we follow the condition that I should be less than or equal to J. So on having, so what happens means we will be replacing the we are converting the indirect left recursion to the direct left recursion and implementing the removal of left recursion. Same thing. So this is how it is being done. That is here S derives A and A derives S is indirect left recursion. So what we are doing, we are replacing, we renaming as S with A1 and A with A2. Now this part is called as I, and this part is called as J, A with the subscript of the A's. So I should be less than or equal to J. So 1 is less than or equal to 2. That is okay. 2 is less than or equal to 1 is not following. So what has to be done is that now we are going to replace that, make it as a direct left recursion. So A2 derives by substituting this productions in this position. So we get A2, AD and BD and then null. right? Because it is also a non-terminal, I mean, it is also a production. B is also a production, then A to A is a production. So A to A, D, then B, D, then null. So after this, what we are going to do, it is direct left recursion now. So in the same Morse method, we are going to implement, and then left recursion will be removed. So next concept is left factoring. Even for parser developments, we don't want left factor grammars because they increase the chances of backtracking. So program will not be much clear that which production has to be handled. So left factoring of the grammar is that it transforms the useful production to a grammar suitable for the predictive parsers or top-down parsers. So this is an example. So when it is in the format, A derives alpha beta 1, alpha beta 2 till alpha n. That means absorb properly when you are having, so here alpha is there, here alpha is there. So how many productions are there? We are having alpha. So what is the meaning that? So whenever are trying to impose the production, so first production will be tried since the wanted suitable language production is beta n. So n times it will be implementing the solution and trying and getting the solution back. So to avoid it, what to be done is this increases the chances of backtracking much. So the alpha will be specified as a single the string, and then the a dash, a new non-terminal will be dealing with this betas. A new non-terminal will be introduced and will be given as a new production here, right? So this way we can remove the left factor of a grammar. So taking this example, S derives IETS, IETS EC A. What is happening that we can clearly visible that IETS in the first production, IETS in the second production are common. So what we are doing, we are introducing a new non-terminal S dash where it will be dealing the rest of the string ES. Since it is, I mean, till this only it is not having any extension, means null will be imposed. Then the remaining parts are as it is existing, right? So this is a left factor grammar. So in view of parser constructions, it is compulsory that ambiguity should not be there. It must to be eliminated where our left factoring and left recursion is very much important. Thank you.